Now, next boiler problem is carryover. It is the phenomenon of carrying of water along with impurities by steam is called carryover. Foaming and priming are collectively known as carryover. When a boiler is steaming, that means producing steam rapidly. Some particles of the liquid water are carried along with steam. This process of wet steam formation is called priming. Priming is caused by the presence of large amount of dissolved solids, high steam velocities, sudden boiling of water, improper design of boiler, sudden increase in steam production rate. Now the disadvantages of priming. It reduces the efficiency of boiler. It decreases the life of machinery. And the actual height of the water column cannot be judged properly. Now, the prevention of priming. By improving boiler design, by fitting of mechanical steam purifiers, by maintaining low water level, by using soft water, by decreasing the amount of dissolved salt in boiler feed water, by doing internal conditioning. Now, foaming. It is the production of foam or bubbles in boiler feed water which do not break easily. Causes of foaming. Foaming is caused due to the presence of oily substances in water, low water level in boiler, sudden increase in steam production rate, the presence of dissolved salts in water. There are some disadvantages of foaming. Actual height of the water column cannot be judged. Dissolved salts in water carried by wet steam may damage turbine blades or machinery parts. Foaming can be avoided by removing oil from boiler water by adding compounds like sodium aluminate, by adding anti-foaming chemicals like castor oil. Priming and foaming occurs together. They are objectionable because dissolved salts in boiler water are carried by wet steam to superheater water and turbine blades where they get deposited as water evaporates. This deposit reduces their efficiency, decreasing the life of machinery. Now, foaming. Boiler water carryover is the contamination of steam with boiler water solids. Bubbles or froth actually build up on the surface of the boiler water and pass out with the steam. This is called foaming, and it is caused by high concentration of any solids in the boiler water. Foaming tendencies are increased with the increase in alkalinity and solids content. Stable foam bubbles contain boiler solids and are carried forward with the steam, giving rise to carryover. Now, the foaming is the production of foam or bubbles in boiler which do not break easily. Now, the causes of foaming. It is due to the presence of oily substances in water, low level of water in boiler, sudden increase in steam production rate, the presence of dissolved salts in water. There are some disadvantages of foaming. We cannot judge actual height of water. Dissolved salts in water carried by the wet steam may damage turbine blades or machinery parts. Foaming is prevented by removing oil from boiler water by adding compounds like sodium aluminate, and also by the addition of anti-foaming agents like castor oil, gallic acid and tannic acid. With respect to foaming, water can be of following grades. First is foaming water. It is the water which produces foam even in 2 days if blowing off operation is not done. Semi-foaming water. It is that water which does not produce any foam in locomotive boilers for 2 days. Third is non-foaming water. It is that water which does not produce any foam in locomotive boilers for 1 week. Now, last boiler problem is caustic embrittlement. Caustic embrittlement is a type of boiler corrosion caused by using highly alkaline water in the boiler. During softening process by lime soda process, free sodium carbonate is usually present in small proportion in the softened water. In high pressure boilers, sodium carbonate decomposes to give sodium hydroxide and carbon dioxide. The formation of caustic soda makes the boiler water caustic. The NaOH containing water flows into minute hair cracks by capillary action. Here, water evaporates and the dissolved caustic soda concentration increases progressively. This caustic soda attacks the surrounding areas, thereby dissolving iron of boiler as sodium ferroate. This causes embrittlement of boiler parts, particularly stressed part like bands, joints, rivets, etc., causing even failure of the boiler. Caustic embrittlement can be avoided by using sodium phosphate as softening reagent instead of sodium carbonate, by adding tannin or lignin to boiler water. These blocks hair cracks, thereby preventing infiltration of caustic soda solution. By adding sodium sulfate to boiler water, sodium sulfate blocks hair cracks, thereby preventing infiltration of caustic soda solution. By adjusting the pH of the boiler feed water between 8 to 9,